All right, so let's get someone's results. How many groups think they found the pattern to the staircase frame from Friday? All right, Dana, go ahead.
After 18, it goes 28, 40, 54, 70, 88.
All right, how many groups got that same table? Okay, so you start to see the pattern, right? We won't discuss it now. We're going to talk about it when we it's in a couple problems ahead. So once we go from 4 to 8, 4 to 10 to 18 to 28 to 40 to 54 to 70 to 88. So we didn't get a chance to do this on Friday. Wrong way. We didn't get a chance to do this on Friday. So what I want you to do right now with your group mates, I want you to take about 5 to 7 minutes. I want you to graph this, describe your pattern of change. So basically answer 2, 3, 4, and 5. Okay? And talk about what are the patterns that you see. I'm sorry, up to 4. Describe the pattern that's shown in the table. How is it shown in the graph? And since everyone got it, most of you are going to probably have the same answer. So with your group right now, take that time to graph it and answer 3 and 4. We are going to talk about number 5. I'm going to give you 5 to 7 minutes. All right, go. So what do you notice about the table and the graph? What could you say about this, the model of these steps? How does it compare to the truss? Jamie? Okay, the steps increase, the rods do increase, right? What else could you say? What kind of model is this? Is it a linear model? Why do you say no?
It's not going up by a constant rate of change.
Okay, from the table, it's not going up by a constant rate of change. Doesn't your line have a slight curve to it? All right, so it's not straight. All right, so how did you describe the pattern of change in the number of rods as the number of steps increased? Right? So I'll start it off for you, right? As the number of steps increase by 1, how can you finish the sentence? What pattern did you notice? Since everyone got the same table values, you should have noticed the same pattern. What could you say? How do the number of rods increase? By what? The rods go up by 2, so it goes 2, 4, 6, 8, 10. No. How can we put that into words? Okay. So 6, 8, 10, 12. What kind of numbers are those? So it maybe increases by the next even number, right? Because we're skipping all the odds, right? There's no increase by 1, 3, 5, 7, 9, right? It's always 4, 6, 8, 10, 12, 14, right? Everybody with me on that? So we can say the number of rods increased by the next even number. Or from what Dana said, you could even say by 2 from the previous number, right? Wouldn't that also work? If I go back and look at my table here, right? So this increases by 6, right? So the next one should increase by 2 from the previous number, which is 8. And then 10. And then 12. And then 14. And then 16. And then 18, right? I saw this on one paper. Let me know how many people else found this, but If I take the difference of the difference, they call it the second difference. Look at what's constant. Does anyone else have that? I just see that with one group. All right. So there's a reason why this line has a curve. This is called the quadratic. You're not going to learn this till next year, but at least you can hear the word. A quadratic is obviously not straight because you've seen that in the line, but it's actually, their graphs are usually like a U-shaped. So what I can do is if I cut this thing in half of it is the same shape as the other one. You could reflect it. Like if I were to fold it in half, the line goes right over each other. So that's what a quadratic is. So that line that you're seeing, there's another half of it. You're just not seeing the other side of it. That's what it's called. So it's not linear, is it? Because it's not straight and it doesn't have a constant rate of change. This is not a constant rate of change. Just a little preview. Oop. I hate this thing. All right. So again, how is our pattern shown in the table? Well, we just kind of talked about it, right? The number of rods increasing by the next even number, 2 from the previous, right? And we even kind of just showed that little second difference thing there. How's it shown in the graph? Well, the graph, you can't see that it has a non-constant rate of change because it has that slight curve to it. I kind of ran out of real estate. On my graph, I went all up to 75 on here, but on here I couldn't go that high. Maybe I should have went by a different interval. Maybe 8s or something. Still works. I was able to see enough points to know that's not straight, right? I know for sure that's not straight. All right, so let's see how we can figure this out now. Because with the truss, we had to come up with a structure larger than what we were given, right? Well, we're going to do the same thing here. So how many steel rods are in a staircase frame with 12 steps? So in your picture on the other side, they've gone up to 3, right? And in your graph, or your table, I should say, they've gone to 8. Okay, that's the highest number of steps that you've seen. So again, without drawing the frame, how could you figure out how many rods are in a 12-step staircase? All right. So I'm going to give you and your group, this won't take as long as the truss one, so you and your group can go ahead and figure this one out. And I wouldn't worry necessarily about an equation because you don't know enough about quadratics to come up with an equation, but you should be able to figure this out. All right, so we'll give you guys about 5 minutes. All right, so most of you expanded it, right? What answer did you get for 12 steps? 180. So at 8 steps, it was what? Right? At 8 steps, it was 88, right? Which was an increase of, was that the 18 one? All right. So you know the next one has to increase by, because the next even number, right? So the 9th step would have an increase of 20. The 10th step would have an increase of 22. The 11th step would have an increase of 24. And the 12th step would have an increase of 26, which is 180. Now I'm going to go to the table because, like I said, this one group had a really, really, really neat way of thinking. So I'm going to erase this. I'm going to keep the numbers here. But it's easy to see when they talk about here. So, William, what did you guys come up with? Because I really liked how you guys thought. Yep. Okay, so they said in this first cell here, they took 4 and divided it by 1 to give themselves 4. 10 divided by 2 gives you 5.
And we just kept doing it. So we ended up multiplying it by like 1 times 4, 2 times 5, 3 times 6, and then ended up giving us the answers to the number of rods. So we
Yeah,
just kept going on until we went to 12 times 15, and we got our answer.
yeah, here's the neat thing. When I write all this out, look, when you divide the number of rods by the steps, look at the increase. 1, right? So then if I go to, when we did 9 steps, that was what? 108, which is 12. So they said, okay, if they followed that same pattern, instead of going to this now, they just went, okay, well, if I go 10, 11, 12, this should go up by ones, 13, 14, 15. And what they did is multiplied it, and when you multiply 12 times 15, it's 180. I just thought that was a really, really cool way of thinking that most people that I've seen over the few years we've done this book haven't thought about it that way. So I thought that was really neat. They found a whole different pattern, didn't they? Came to the same answer, but another route. All right, so I just thought we would share that because I thought it was just a really, really outside the box way of solving that. Most people, it's really straightforward, right? Just boom, 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 expand your table, be done with it. And they found a whole different pattern, so I thought that was pretty cool. All right. So it says, how is the pattern in question A similar to the pattern in question B, and then how is it different? Well, how will we say it's similar? So how is the truss problem and how is the problem with the staircase similar? How are they similar? Think back to what you did with the staircase. Think back to what we did with the truss. What are some things that we could say is similar? Not everybody at once. Don't look at it too deep. Look at it very for what it is.
Using rods.
Okay, they're using rods, same materials, okay? What else? Okay, the x-axis is increasing by 1. What else?
Both graphs increase.
They're both increasing. All right, what's different about them? What's the big difference with both of these? Anna? And the other is? Yeah, the truss is linear. The staircase is nonlinear. And we actually said for the word of what the staircase actually is. Anyone remember what that word is? Quadratic. A word you'll hear next year. A quadratic graph looks like this. Its parent function. The x is squared. That's how you get the curve, right? Because if I take 2 and square it and negative 2 and square it, don't I get the same number? That's how you get the u. Okay. Is there anything else different about them?
One's table, one's a graph.
Well, they both use tables and graphs. I mean, obviously, we could say the lines, but again, where it goes linear, nonlinear, right? That's the big difference between the two. So let's look at what we did from investigation 1.1 to 1.2 to 1.3a and b. All right, in 1.1, right? We found out that we had 2 examples actually, right? Both were increasing graphs. And we had a nonlinear model, right? I think in the first one, right? The cups. Some people had a linear model, some people had nonlinear. I think more than not, most people have more nonlinear than linear, right? So we dealt with 2 models there, right? Depending on what set of cups you had, right? The foamy cups had more of a pattern to it than those plastic ones we did, right? Everyone with me? I know it's Monday. Time to wake up, rise and shine. All right. In the second one, we did the squares, right? The area. What kind of graph was that? Was it increasing? The area. And we did the areas. As length increased, what'd you see the width? Huh? It decreased. Right? If you had an area of 24 and we start with 1, you had 1 and 24, right? And then 2 and 12 and 3 and 8, right? That slowly decreased, right? Remember the curve? And that was obviously nonlinear for sure. And then in 1.3, our first part, the truss, right? We had a graph that was increasing or decreasing. Huh? Increasing. Yep, the truss increased, right? The number of rods to the length. And it was what? Linear or nonlinear? It was linear. And then this last one that we just did, the staircase, was that increasing or decreasing? Increased, right? As we moved up on steps, we increased the rods, and it was nonlinear. So we saw a few different models here. We saw a straight line. We saw a line with no pattern whatsoever. We saw this. Remember, this one had this nonlinear one, that the couple that we did with the plastic ones, the cups. It had no pattern whatsoever. There was no, like this one down here, this pattern, which was nonlinear, but it was quadratic. It had a pattern, right? Where this nonlinear up here did not have a pattern. All right. So you can see a lot of different models we've covered over the first investigation. All right. You have some class time to work on your homework, which is 5 problems. So we're going to wrap that up right here and stop.